luck, 111 students. We're getting started today with 5.2, and we're going to learn real quickly the basic trigonometric functions. So hopefully you are already familiar with these, and this will be a review. You really should be. Sine, cosine, tangent, cosecant, secant, and cotangent. All right. So let's look at these real quick. Share with you my PowerPoint. Here we go. And let's go ahead and start our slideshow. All righty. Find the values of the basic trigonometric functions. We're talking about sine, cosine, tangent, cosecant, secant, and cotangent. And these are all being formed by right triangles. A right triangle means that it has this right angle highlighted with the little square. And so remember, a right angle is 90 degrees. So that angle right there is 90 degrees. All three angles here are going to equal 180. So theta represents this angle here. We could have something, maybe a beta or something, some other Greek letter here to represent that angle. All three angles would be adding up to 180. So since it's a right triangle, the other two would have to add up to 90. All right. So let's talk about these basic definitions. So if we draw our right triangle, your book likes to use A, B's, and C's, and that's helpful with the Pythagorean theorem, right? A squared plus B squared equals C squared. We've been doing the Pythagorean theorem for a good while. But the A's and B's are the two sides that touch the right angle in the right triangle. The C is the hypotenuse. The hypotenuse is the side opposite of the right angle. Okay. Now, let's let this angle theta, right here is our theta. Okay. And that's going to represent that angle right here. You could have theta over to be this angle. But the way we define sine is sine will be the opposite side. So here is the opposite side of our theta over the hypotenuse here, opposite over hypotenuse. Cosine is the adjacent side, so the side touching theta over the hypotenuse. Tangent is the opposite side over the adjacent side. Now, notice that your book is using A, B's, and C's. The C is easy enough to keep straight. That's the hypotenuse. The A's and B's are harder to keep straight. So I do not use the A, B, and C language when defining sine, cosine, and tangent. I always use the word. So sine is the opposite over the hypotenuse of whatever angle theta you're talking about. Cosine of theta is the adjacent over the hypotenuse. Tangent of theta is the opposite over the adjacent. All right, now, cosecant is the inverse, or the reciprocal, I should say, because actually trig inverses are a little different. It is the reciprocal of the sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse. Its reciprocal is secant. Secant is therefore hypotenuse over adjacent. Tangent is opposite over adjacent. Its reciprocal is cotangent, which is adjacent over opposite. Now, in theory, you have done that at some point previously in your math history. So now we can find all of the trig functions here. Now, let me switch my screen to my paper here because I find it just infinitely easier to write on this. So let's find all of our trig values here. If I'm given a right triangle, okay, there's the right angle on my triangle. I have some angle theta, okay, some angle theta, and I know that the base or the side touching theta was 5, and I was given that the hypotenuse, the side opposite the right angle, was 13. And I can use, in a right triangle, I can use the Pythagorean theorem to find the other side, okay? So it's A squared plus B squared equals C squared, where A and B are the two sides. So I know one side, 5 squared. Do not know the second side. but I know the hypotenuse, which is 13 squared. 5 squared is 25, plus b squared equals 13 squared, which is 169. B squared, therefore, is 169 minus 25, which is 144. B, therefore, is the square root of 124, which is 12. So this side here would be 12. All right, now I can do all of these guys. I can do sine of theta, cosine of theta, and tangent of theta. And then once I get those, it will be real easy to find the reciprocals. The reciprocal of the sine is the cosecant of theta. The reciprocal of the cosine is the secant of theta. And the reciprocal of the tangent is the cotangent of theta. All right, sine is the opposite over the hypotenuse, 12 over 13. Therefore, the cosecant is the reciprocal of that. It's 13 over 12. Cosine is adjacent over hypotenuse. So the side touching it, 5 over the hypotenuse, 13. Secant is the reciprocal of cosine, so it is 13 over 5. Tangent is the opposite over the adjacent, so 12 over 5. Cotangent then is its reciprocal, 5 over 12. All right. All right, scrolling through that, but if you want to look at PowerPoint slides for this, that is in there. All right, now, one more thing I want to do here with you, let me stop that share, is do use our fundamental identities. So I got a few more fundamental identities I want to tell you about, and then we're going to use them. Let's see. All right, so that's not what I want. So stop that. I want to share this one. All right, so let's use these guys. All right, so we said there were reciprocals. Reciprocals mean you flip it upside down or 1 over the other one. Quotient identities is you can also find tangent because it is sine over cosine. Cotangent is also cosine over sine. They're all basically the same idea, but just that you can keep writing them another way. So tangent is also sine over cosine. So pause me, make sure you get all of these guys written down so you have them somewhere. Now in our first test, we're not going to use cheat sheets, but then we will use cheat sheets ongoing. All right. Now, let's say that the sine of theta is root 10 over 10, and the cosine of theta is 3 root 10 over 10. We want to find the values of the rest of them, okay? Several ways we could think about it, but let me share back my other screen because it's just so much easier to write. Okay, so new information I've given you. Let's zoom in a tiny bit here. New problem. The sine of some theta is root 10 over 10. And the cosine of theta is 3 root 10 over 10. Now we did just have, and they want us to find everything else. Okay, find everything else. Now we should just have a rule that the tangent of theta is sine, so root 10 over 10, over cosine, 3 root 10 over 10. And we could use that. You need to remember all the things that you've learned in previous math classes. So how do you divide fractions? Well, this is root 10 over 10, the top, divided by the bottom, and we divide fractions by multiplying by the reciprocal. So 10 over 3 root 10. Okay. So root 10 over 10 divided by 3 root 10 over 10 is root 10 over 10 times the reciprocal, 10 over 3 root 10. Is that coming back to you? And then that simplifies super easy as just 1/3. So the tangent is just 1/3. Okay. Now, we don't even have to draw the triangle. You could if you wanted, but you don't have to. The cosecant then of theta is going to be the reciprocal of root 10 over 10. That is 10 over root 10. But if you remember anything from annoying previous math classes, you know we do not leave radicals in the denominator here. We have to rationalize our denominator. So we're going to multiply the top and the bottom by root 10 over root 10 to rationalize that denominator. That gives us 10 root 10 up top. And root 10 times root 10 is the root of 100. And the square root of 100 is 10. Now, these two 10s will cancel out, and I get that the cosecant is simply root 10. All right. How about the secant then? Okay. That's cosecant. All right. Secant is going to be the reciprocal of the cosine. The cosine was 3 root 10 over 10. So the secant is going to be 10 over 3 root 10. Pardon my little squiggly line. Okay. 10 over 3 root 10. Cannot leave the square root in the bottom. So we have to rationalize our denominator. We have to multiply the top and the bottom by root 10. Up top, that gives me 10 root 10. Okay, on the bottom, I have 3 times root 10 times root 10. Okay, 3 times root 10 times root 10 is 3 times root of 100 is 3 times 10, which is 30. Okay, it's 30. Now, let's say you didn't know what that was. Hey, what we have, graphing calculators. So I've got 3 times root 10 times root 10, drum roll, 30. All right, so the bottom there equals 30. 10 goes into 33 times, and I end up with the secant of theta is root 10 over 3. If you are having problems rationalizing the denominator, please go to YouTube, look up a video on rationalizing fractions or rationalizing the denominator of a fraction. Just freshen up on that. You're going to need that a little bit. All right, so that was sine, cosecant, cosine, secant. Now we just need the inverse of the reciprocal of the tangent. That'll be the cotangent. So the cotangent of our theta is going to be 1/3 the reciprocal of that, which is 3 over 1, which is 3. All right, good. That was easy enough. And that is in our PowerPoint slides as well, but I don't know that you need it. All right. Next, I would like to show you this screen with a few more what we call Pythagorean identities. So if you're familiar with the Pythagorean theorem, a squared plus b squared equals c squared, these are versions of this. They look different, but they're not really different. And the primary one here is the sine squared theta plus cosine squared theta equals 1. That one is super duper important. So what do we have so far? We have, let's see if I can get this to come up. We have this. These are our basic identities and probably the ones, I think you should be reasonably comfortable with these. All right, so let's put these to work a little bit. If I give you the sine of 39 degrees divided by the cosine of 39 degrees, well, sine over cosine is tangent. So what do we got here? We just got the tangent of 39 degrees. This is tangent of 39 degrees minus the tangent of 39 degrees. What would that be? 0. Okay. All right, how about letter B? Now, we might need a little more help to think about this, although I will tell you 1 over something is the reciprocal of it. So what's the reciprocal of cosecant squared? That's sine squared. So we're basically saying the cosine squared of pi over 4 plus the reciprocal of the cosecant squared, which would be the sine squared of pi over 4. And we just had a fundamental identity that says cosine squared plus sine squared equals 1. So therefore, those were pretty doggone simple if you know your identities. All right, Tay. Well, let's see. Let's go ahead and keep going. I think y'all can handle this. I sometimes like to make a lot of shorter videos, but I am going to go ahead and persevere through this one. By the way, our keyword today is water buffalo. Water buffalo. All right, so we're going to continue on. I am recording this, am I not? Yes, I am recording this. Okay, we're going to continue on. So let me share the screen again with you. And we are here. Current slide, finding the values of the remaining trigonometric functions given one of them. All right, so let's say I tell you that the sine of theta is 1/2 and theta is an acute angle. This one, probably the most straightforward way to solve it is for us just to build a triangle and set it up and deal with it, okay? So we're told an acute right triangle. So we got the right triangle, and we know that the sine of some theta, I don't know what it is 1/2, or sine of theta is 1/2. Remember that sine is the opposite over the hypotenuse. So opposite is 1 over the hypotenuse is 2. So I know the opposite and the hypotenuse. I just don't know that third side. However, I know the Pythagorean theorem. So that third side is super easy to get. A is 1 squared plus some other side I don't know equals 2 squared, the hypotenuse squared. So 1 plus b squared equals 4. So b squared equals 3. Take the square root of both sides. B equals the root of 3. Okay, so I've got 1, 2, and the square root of 3. All right, well, I can find everything else then. Cosine of theta then is the adjacent over the hypotenuse, root 3 over 2. Tangent theta, therefore, is the opposite over adjacent, 1 over root 3. However, math, offense alert or something. You can't have leave the square root in the bottom. So we got to rationalize the denominator. And we end up with root 3 over the square root of 9, which is 3. Root 3 over 3. So now I've got sine, cosine, tangent, and now I can find the reciprocals. The reciprocal of sine is cosecant. Reciprocal of 1/2 is 2 over 1, which is 2. The reciprocal of cosine is secant. So that's 2 over root 3. Uh-oh, can't do that. All the math people get mad. And so we end up with 2 root 3 over the square root of 9, which is 3. So 2 root 3 over 3. And then the reciprocal of the tangent is the cotangent. And let's just go back to the beginning. The reciprocal of 1 over root 3 is going to be root 3 over 1, which is root 3. All right, Tay. So given 1, you can find all of the others. All right, continuing on here. I got all of this in my. All righty. They did it several different ways. Sorry, just looking through if there's anything else we have not yet done here. I think we're pretty good. All right, last but not least here in 5.2, complementary angle theorem. All right, because we are in a right triangle, these two angles, theta and whatever the other one is, 90 minus theta is what it's basically going to be. All right, so whatever the one angle is, B or A, the other one is 90 degrees minus A, okay? And what we'll find is that the sine of B will equal the cosine of A. And the sine of A will equal the cosine of B. And the cotangent of B will equal the tangent of A and vice versa. They're all interrelated. So cofunctions of complementary angles are equal, all right? So the cofunctions are sine and cosine, tangent and cotangent, cosecant and secant. The cos, all right? So this is cofunctions, that's why we use the cos. So you might think, well, why aren't sine and cosine the reciprocals? Well, they're not. They're the cofunctions, and they are related by this complementary angle theorem. Cofunctions of complementary angles are equal. That would be sine and cosine of complementary angles are equal. Tangent and cotangent are equal, and secant and cosecant are equal. So the sine of 79 degrees would be equal to the cosine of 11 degrees. See what I'm saying? 90 minus 79. About the tangent of pi over 18. I know you guys are going to crawl into every year. Kids absolutely hate fractions. But I'm sorry, I mean, this is trigonometry. You're going to just have to bucket up and finally learn your fractions. All right, but what were we given? Pi over 18? I can't remember what it was. Was it cosine of pi over 18? All right, well, instead of 90 degrees, this will be the sine of 90 degrees is pi over 2. So pi over 2 minus pi over 18. Okay, and you can do this. You just get common denominators. Let's just pretend like we're not going to curl up in the fetal position because we have to do fractions with pi's. What do you do if you subtract fractions? You have to get a common denominator. What's the common denominator between 2 and 18? 18. So we have to multiply the top and the bottom by 9 to get a common denominator. Okay, try to go back to middle school math. 9 pi over 18 minus pi over 18 is 8 pi over 18. But I have to reduce. So let's see. Divide them both by 2. 4 pi over 9. Now, here's a really lovely thing. If you hate fractions, and heaven knows the vast majority of my students do, your calculator can help you with this, all right? Now, it's not going to help with the pi's, but just think about the fractional part of this. This is basically 1/2 pi minus 1/18 pi. Let's just deal with the fractional part, okay? 1/2, 1 divided by 2, minus 1 divided by 18. That's not what I want. No, I don't want puffer. I want it in fractional form. All right, well, here's why we use this calculator. Hit math. Number 1, convert it to a fraction, press enter. 4/9. 4/9. So 1/2 pi minus 1/18 pi is, and we found that, 4/9 pi, or 4 pi over 9. So if you absolutely hate fractions, learn how to do them on the calculator, okay? Put yourself out of misery, and it's that math frac button. So you can just enter them in. See how I entered them just basically as the division. 1 divided by 2 minus 1 divided by 18. Got the decimal form, converted to a fraction, and then added pi. You're welcome. All right, with that, I believe we have finished everything we need to do in this one. And so your keyword was water buffalo. I went to Kenya recently, or like a year ago, and saw a lot of water buffalo. And so that is your keyword for today. All right. Email me your keyword so I know you're taking part in the class. Also, wh@octech.edu. And feel free to use the Ask the Instructor button in your Pearson homework if you need help. I try to be pretty fast with that. And you can always call me at 268-2516, and I'll try to get back to you as soon as I can. See you later. Bye.